Today we are solving 121st question on LeetCode, best time to buy and sell stock. Let's read the description. So you are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day, to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, so the first input we have is a number of prices, and for output should be 5. Explanation. Okay, you buy on day 2, price is equal to 1, and sell on day 5. Price is equal to 6. Profit will be 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. That makes sense. So we must buy at some date and sell on one of the following dates so we can get the maximum price. Second example we have here is another array which is in decreasing order, and output is 0 because if we buy at any given day, the stock is decreasing on the next days, which means we can only have a minus, we will never have a profit. That's why we just return 0 and say maybe let's not do any transactions. Maximum profit we can get from this list is 0. Okay. So the constraints: prices will have at least one number or more, and every item inside the prices will be positive between 0 and 10 to the power of 4 range. Okay, the question is clear, and for the note, this is the first time I'm solving the question as well. Let's get into it. Let's try to understand the logic. What's happening? We are given the price of stock in some number of days, depending on the array length, and let's find the output. Okay, how can we do that? If we could have found the thing that we want to do is to find the minimum and maximum of that array and the difference, getting that difference. That's what we want. We want to find the maximum, we want to find the minimum, and the difference will be our profit. But there is one condition which says, for example, if we had an array we had the 1 at the end. If we had 1 at the end, then we cannot solve. We cannot take 1 and 8 because 1 comes after 8. That breaks our condition. Okay, that breaks our condition. In such a case, we check the value, takes the next, we should find the least value followed by bigger difference that results in bigger difference. It is okay, what is the logic behind? Let me think. Okay. What I'm thinking about is like having maybe 2 pointers to see where both of them will start. For first one will start at the beginning, second one at the end, and every time we will compare the values and move one of the pointers. The problem I'm facing is like which pointer should I move? Um, okay. Okay. If you use a for loop, for example, if we check a number and say that's the minimum we have found so far, and check the next number, we see it's less, so we can say this is the minimum we have found so far. And also maximum, how do we keep track of maximum? When we go to the next number, we compare it with the minimum, and if it is less, if it's bigger, we can say our current maximum is 5 and difference is 4, and we keep moving. But this maximum is actually should be current maximum, because this when I move from 5, which means this one is can no longer be the maximum, because if I take 3 and 5, I cannot do that, because like day 3 has already passed, we are at day 4. So I will keep my minimum, and when I reach 3, I check to compare 1 with 3, and also the difference will be 2. I do not replace the difference. I can, yeah, it's also current maximum. If we look at a day like this today's maximum, it validates the case where 1 is bigger than 3, and difference is 2, but we do not want that, so we can just move. We actually do not need this. I see we will just keep track of difference, minimum, and the current we are looping. And next we move here, we see 6 and calculate the difference. We are not resetting our minimum because it's not less than our minimum. The difference becomes 5, it's bigger, so we replace 5, and we go to the next one, and we see that it's 4. 4 is still bigger than 1, which means the difference is 3, but the difference is less than the current one, so we just return we do not update the difference, and we return it at the end. Will this logic work in a case like this, where our difference is actually 0? So let's say we have minimum, which will be initialized as the first number, and the difference, which will be initialized at 0. And at this day we see that we have minimum 1. We can actually start iterating from the second index, and we check what we are doing. First step, check with minimum. Okay, we have 2 cases for that: less than minimum, update minimum. Current, let's say current is what's tracking this. This is our current, is less than minimum, update minimum. Else, we have the second case. It's actually second case, which is actually our else statement. More than minimum. If it's more than minimum, we wanna update difference. And depending on that, like we also check while updating, we also check is it less than, is it more than our current difference, and if they are equal, we just skip it. Okay, so we are now starting with 8. 8 is our current. Let me write here current. And now we check, is 8 less than minimum? No, it's not. Is 8 bigger than minimum? Yes, so our difference should be updated. It can either be 0 or 1. We take the biggest one, so it's 1. We move and we check, is the current less than our minimum? Yes, it is. So let's update our minimum. Our minimum now becomes 5. And we move and we see 3. 3 is less than minimum, then just update the minimum. Now minimum is 3. And the next value we have 6. Is 6 more than minimum? It's not less, so it's more than minimum. We update the difference. What's the difference between 3 and 6? It's 3. So we have 1 and 3. We take the bigger one, which will be 3. And we move. Is 4 less than minimum? No. Is it it's not less than minimum, but it's more than minimum, which gives us a difference of 1, but we still keep 3 because it's bigger. We move, and here we see our 1 is less than our minimum, current minimum. We update our minimum, and when we exit the loop, finish the loop, our difference will be 3, and that's the correct answer. It will also work for cases when it's only decreasing, like 4, 3, and 2, and 1. Because our minimum at the start will be 4, we will iterate from the second array, difference will be 0. Here, so in this case, we have minimum 3 right now, and we move our cursor, current, it's 2, we check it's less than our minimum, let's update our minimum, and we also check, and we also, this case 1 is less, we update our minimum, and we finish the loop, we see that the difference is 0, we return it. So that's the logic. The time complexity and space complexity. So what do you think? Pause the video and think about it. Okay, for this one, time complexity will be big O of n. N is the length of array length. And space complexity will be big O of 1, constant time, because we are not storing any other array or anything. We have some variables that will stay the same. Yes, that's it. Let's code it. Okay, let's code it. If you want to code it yourself, you can again pause the video right here. Otherwise, I will go on and code it. Start coding. Okay, it's not. Yeah, this is what I want. Let's write our loop. Let's initialize our values first. Let minimum equals to prices at 0. Okay, let difference initialize at 0, and our for loop, let number price of prices, it will give me prices on every place in the list, one by one, of prices. Also right here, return difference. Okay, we check if price less than minimum. Okay, minimum should be this price, and second condition, else if price is more than minimum. We wanna update the difference. Difference is math dot max of okay, let me max dot max of, it can either be our current difference and price minus minimum. We want to get the maximum of these two, and at the end we just return the difference. We don't care about the cases when price and minimum are the same. It doesn't matter. Okay, accepted. So our solution passed. Okay, let's now go to the solutions and check out the best solution. Actually, another way to do runtime and memory check is I would go to this panel and check like the fastest solutions. How do they work? Okay, so we have result, current, next. If next is less than prices dot length for iteration. Okay, result is our current difference, prices next minus prices current. When prices current is bigger than prices next, current becomes next. Next plus. Okay, it's doing the same logic, but with a while loop in a slightly different way. Do we have any other solutions? Min price, max profit. Okay, they are getting this and starting the loop. The same logic. Minimum if we find a smaller price, update maximum if selling at the current price yields a larger profit. That's great explanation. I like this code. So most of them are the same, I think. We can also go to the solutions and see the top ranked solutions. If there are better than us, like even if you solve the question 100%, even if you are very happy with your solution, at least check top 3 solutions given by others. Okay, so they are also doing the same with 2 pointers. They are doing the same with 2 pointers. What they are doing is like instead of 1, they have 2 pointers, looping with pointers, and while loop, both like this. 1 pointer has the minimum and second moves. If it's less than minimum, they say this is our minimum. The same logic basically, and then move the second pointer, gets a difference, move the second pointer, gets a difference, move the second pointer until it's less than the second one. We don't update and move it. When the second pointer exits the loop, like with larger, bigger than the array length, they exit. Okay. Slightly different variations of our solution. Okay, so there is also a brute force approach that I haven't talked about, which is like you take one and compare it with all the elements. You take then the second number, compare it with all the remaining. You take 5, compare it with all the remaining. You take 3, compare it with all the remaining elements, which will be like O n squared. this is how it's explained, like you take 3, you take all, 8 all, 1, like all the next items we take it. But it's also the same logic, same explanation, so seems like our solution was a very good one, and I didn't find any better solution, but the explanations here are good, like at least even if your solution matches the ones on the top, it will be good to read the explanation and it may help you to explain your solution better if next time any questions related or similar to this comes up. Okay, so that was day 7. Thanks for watching, subscribe and keep coding. Bye.